Solar panels are not going to save you. And no, this isn't some anti-clean energy rant. This is about math. Because right now, in 2026, if you call up a solar company and ask them to install a system on your roof, the federal government will give you exactly $0 back. Not 30%. Not a discount. Nothing. That program is dead. And nobody selling you a $30,000 system is going to be the one to tell you that. So today I want to show you something that costs less than a fast food meal, has been proven to work for almost 200 years, and doesn't need a single dollar from Washington to keep your lights on. It's called an earth battery. And by the end of this video, you're going to understand exactly why it works, why almost nobody talks about it, and how to build one yourself for under 10 bucks. Let's start with the number that should make you angry. The average American household spends around $150 a month on electricity. That's over $1,800 a year, every year, forever, just to keep the lights on. So naturally, a lot of people look at solar as the way out. Makes sense on paper. But here's what actually happens when you get quotes. A full solar setup for your house runs somewhere between $14,000 and $28,000 before any incentives. Add a battery so you actually have power at night or during an outage, and you're adding another $7,000 to $19,000 on top of that. Want whole home backup, the kind that runs your fridge, your AC, everything during a blackout? Now you're looking at up to $34,000 just for the battery portion. Go fully off-grid, no utility connection at all? That can run past $100,000. And up until recently, the government helped soften that blow. There used to be a federal tax credit that covered 30% of the cost of solar and battery systems. It was supposed to run until 2034. Then in 2025, a law called the One Big Beautiful Bill Act killed it 9 years early. Not reduced it, not phased it out slowly. Killed it completely, effective December 31st, 2025. If your system wasn't installed and running by that date, you get nothing. Zero. The only way left to get any kind of federal break is to lease your system from a company instead of owning it outright, which means you're back to paying someone else forever anyway. So let's say you do it anyway. You pay full price, no help from anyone, and you install the lithium battery that every solar company pushes as the heart of the system. Here's the part they don't put on the brochure. Those batteries lose capacity over time. Real data on these cells shows they can lose around 15% of their storage capacity within about 5 years, and under heavier use or heat, that number climbs even higher. Most home battery warranties only guarantee 60 to 80% of the original capacity after 10 years. That means the battery you paid thousands of dollars for is quietly getting weaker every single year you own it, and at some point, you're paying full price to replace it. That's not energy independence. That's a subscription you didn't sign up for. And is the grid even reliable enough to make all this worth it? In 2021, the average American household dealt with about 7 hours of power interruptions over the course of a year. That's not a small number. Some states had it way worse. So you're paying more than ever for equipment that loses value every year, backed by a grid that isn't getting any more dependable. That's the problem. Now let's get into the part that changes everything. The ground under your feet has been generating measurable electricity since before your grandparents were born. It doesn't wear out from cycles like a lithium battery. It doesn't need a service contract. It doesn't care if it's cloudy outside. And the science behind it isn't some new experimental thing. It was proven in 1841. Here's how it actually works, and I promise this is simple. If you ever did the classic science experiment where you stick a copper penny and a zinc nail into a lemon and it powers a tiny LED, you already understand this. That's called a galvanic cell. The lemon juice acts as what's called an electrolyte, basically a liquid full of dissolved particles that can carry electricity. The copper and the zinc are your electrodes. And the reason you get power out of that setup is because zinc and copper don't hold onto their electrons the same way. Zinc wants to give up electrons. Copper wants to collect them. When you connect the two through a wire, the electrons have no choice but to flow from the zinc to the copper. That flow is your electric current. An earth battery does the exact same thing, except instead of a lemon, you're using wet soil. Soil naturally has dissolved minerals, salts, and moisture in it, which means it can act as an electrolyte too. It's not as strong as something like battery acid, but it's free. It's everywhere, and it never runs out. One single cell, one copper piece, and one zinc piece buried in moist ground produces somewhere between 0.5 volt and 1 volt. On its own, that's not enough to run anything meaningful. But here's where it gets interesting. If you wire 10 of these cells together in a series, connecting the copper of one to the zinc of the next, you get 5 to 10 volts. Wire 20 together and you're at 10 to 20 volts. That's enough to trickle charge a 12-volt battery. That's enough to run an LED strip continuously. That's enough to power small sensors and low-draw electronics all day, all night, without a single solar panel or lithium cell involved. And unlike solar, this doesn't shut off when the sun goes down. As long as the soil stays moist, the reaction just keeps running. In a normal climate with regular rainfall, that's basically a permanent, ongoing power source. Now here's where I want to slow down, because this next part is the strongest proof that this isn't some fringe internet idea. This has real, documented history behind it, going back further than you'd probably guess. In 1838, a scientist named Steinhale in Munich discovered that the Earth itself could act as a return path for electrical signals, which meant telegraph companies could cut their copper wire needs in half. That single discovery saved the entire telegraph industry across Europe and the US millions of dollars. And by the 1850s, nearly every major telegraph network on the planet was using the ground as part of its electrical circuit. Then in 1841, a Scottish clockmaker named Alexander Bain buried a pair of zinc and copper plates about a meter apart outside his workshop in London. He connected them with a wire and measured about 1 volt of continuous output, enough to power the electromagnetic pendulum in his newly patented electric clock. That's the actual birth of the Earth battery as a working device. A few years later, in 1847, an engineer named W.H. Barlow discovered something even stranger. He found natural electrical currents running through the Earth's crust itself, separate from anything humans built. These are called telluric currents, and they've been measured and studied by scientists for over 150 years since. And then there's September 2nd, 1859. The largest geomagnetic storm ever recorded hit the planet. The natural electrical currents running through the ground got so strong that telegraph stations actually caught fire. Some operators got shocked by their own equipment. And on one line between Boston and Portland, Maine, 2 operators disconnected their batteries completely and had a 2-hour conversation using nothing but the current flowing naturally through the Earth. That actually happened. That's documented history, not a theory. Now let's jump forward to the man who probably deserves more credit than anyone in this story. In 1892, a self-taught inventor named Nathan Stubblefield walked into the town square of Murray, Kentucky, and demonstrated something incredible. He drove metal rods into the ground and used them to transmit clear human speech over distances of up to 6,000 feet. No wires connecting the stations, no outside power source, just the Earth acting as the medium. In 1898, he was granted a U.S. patent for an electrical battery made from copper and iron buried in the ground. In 1902, he demonstrated ship-to-shore wireless communication. And in 1991, the governor of Kentucky officially declared him the true inventor of radio. But by then, Stubblefield had already died decades earlier, in isolation, after destroying most of his own prototypes. His name barely shows up in the mainstream history of electricity. So here's the real question. If this technology is almost 200 years old, and modern researchers keep proving it still works, why isn't it on a single government incentive list? It's not because it failed a test. It's because there's no company behind it lobbying for it. There's no manufacturer sending people to testify in front of Congress. There's no big industry that profits when you bury a piece of copper and a galvanized nail in your backyard. The $400 billion a year electricity industry runs on centralized power plants, transmission lines, and metered billing. An Earth battery generates no invoice. It needs no meter. It just doesn't fit into that system, so it never got built into it either. And this isn't just old history. In January 2024, researchers at Northwestern University published a peer-reviewed study on a soil-powered device about the size of a paperback book. It's a slightly different technology called a microbial fuel cell, which uses naturally occurring bacteria in soil to generate electricity as they break down organic matter. In field testing, this device generated far more power than the sensors attached to it actually needed, and it kept working across a wide range of soil moisture conditions, from fairly dry ground all the way to being fully submerged. The research was backed by the National Science Foundation, the USDA, and other legitimate funders, and the team published their full design publicly so anyone can study it. Now let's actually build one, because this is where it gets real. You need 3 things. First, copper. A length of copper pipe from any hardware store, cut into short sections, works as your cathode. Second, zinc, which you can get from a box of galvanized steel nails coated in zinc. These are your anodes. Third, a small roll of insulated copper wire to connect everything. All in, this costs under $8 at normal hardware store prices. Here's what you do. Dig 10 holes in moist ground, spaced about a foot apart. In each hole, push in 1 piece of copper and 1 galvanized nail, keeping them a few inches apart within the same hole. Then connect the copper from the first hole to the zinc from the second hole, and keep doing that in a chain through all 10 cells. The exposed zinc at the very start of your chain is your negative terminal. The exposed copper at the very end is your positive terminal. Test it with a basic multimeter, and you should see somewhere between 5 and 10 volts. If your soil is dry, water it. If it's sandy and doesn't have a lot of minerals, dissolving a bit of salt into water and pouring it near each cell will help conductivity. Adding some compost can also improve both voltage and current over time. If you want to trickle charge a 12-volt battery, you'll want at least 14 cells wired together, plus a small diode to stop the current from flowing backward. Now, I want to be honest with you about the limits here, because this isn't magic. This will not run your air conditioner, your stove, or your washing machine. It's built for small stuff. LED lighting, sensors, trickle charging a battery, low power electronics. The output depends heavily on how moist your soil stays. So if you're in a dry climate or going through a drought, expect less power. And the zinc parts do wear down over time from the reaction itself, so you'll likely need to replace them every year or two, depending on your soil. But think about what that actually means. For less than the cost of lunch, you get a power source that runs day and night, doesn't degrade the way a lithium battery does, and doesn't need a single dollar from a tax credit that doesn't even exist anymore. It's not a replacement for your whole house. It's proof that you don't need a $30,000 system to start taking a little bit of control back. This is a nearly 200-year-old idea that still works today, verified by actual university researchers just a couple years ago, and it barely costs anything to try for yourself. If you want to go deeper into how this all works, check the description below.